implicit rule of differentiation. And how do we use implicit rule to differentiate? Yes, because this is calculus, and this is a continuation of what we have been doing before. So guys, do not forget, like, share, subscribe to this channel, and more videos will keep coming in like that. Now, how do we use implicit rule to differentiate? Note something, that at every point whenever you differentiate y, always add the y dx. Do you understand? So let's look at the first example. So we have so many examples here. We have x squared plus y squared equals to 4. We have x squared, y squared, blah blah blah, and all of that. So what we want to do is solve these questions one after the other. So I want to solve number one. So if I want to differentiate now, if I differentiate x squared, I'll have 2x. I will not add the y dx because I'm not differentiating y. So plus, I want to differentiate y now, that will be 2y dy over dx equals to, differentiation of a constant will give 0. You understand? So if I bring all these terms together, that is 2y dy over dx equals to, take this to the other side, minus 2x, then divide both sides by 2y, both sides by 2y, cancel, cancel. So dy over dx is equal to minus 2x over 2y. So cancel, cancel, which is equals to minus x over y. So this is the value of our dy over dx. So now, that is how to do it. Now let's pick another example from number 2. Number 2 says that x squared y plus y squared x plus 4x equals to 1. Now this is another different scenario entirely. So how do we do this one? First and foremost, the sign in front of, you say that there are two variables together multiplying each other, x squared and y. So what we want to do is that we'll be differentiating the variables one after the other. Now look at this. I want to differentiate y squared only. If I differentiate y squared only, I will have 2x. Then y, I have not differentiated y yet. But the value of y will also be affected with this. So it will now be 2xy. But I will not add the y there because I did not differentiate y. So then plus. Why am I using plus? Because the starting sign for this question is what? Plus. So plus. Then if I differentiate y now, I will now have, if I differentiate y, I will have 1. So which is what I'm going to be left with, what x squared. So then I will now add the y over dx. Do you understand now? Then plus, now I want to differentiate y squared now in this question. And I'm also using plus because this question has a positive sign. So y squared, when I differentiate, I will have 2y times x. So guys, this question now, like I was saying, that 2xy, since I have differentiated y squared, I will be left with 2axy. But because I differentiated y, I will now put the y over dx. Do you understand? Then plus, I want to differentiate only x. I am using plus because the starting sign is plus here too. So if I differentiate x now, I will be left with what? Y squared. So y squared. But I'm not going to be adding the y dx because I did not differentiate y, but I differentiated x. So then plus differentiation of 4x now will now give us just 4 equals to differentiation of the constant is 0. So now I will now bring all the values with dy dx to the left hand side. The ones without dy dx to the right hand side. That will be 2. Let me make it start. That will be x squared dy over dx plus 2xy dy over dx. Then I will transfer the rest to the other side. That will be minus 2xy. This will go there. Then minus y squared. Then minus 4. So that's it. Then I will now factorize. So if I factorize, dy over dx is common. Then I'm left with y squared plus 2xy equals to minus 2xy minus y squared minus 4. So I'll divide both sides by x squared plus 2xy, then both sides by x squared plus 2xy. So this is our final answer to this number 2 question. So this is how to use implicit differentiation. So I'll be solving number 3 and number 4. So now guys, In this is question number 3. So what we are going to do is that we are going to differentiate them just like we did number 2, due to number 2. So we want to differentiate only y squared. So if we differentiate only y squared, that will give us 2y. Then we are still left with 4x. So if you multiply it together, this is for when you differentiate only y, and don't forget to add the y over the x. Do you understand? So then you now put plus y because the starting sign is plus. Then you now differentiate only x. When you differentiate only x, you are going to have 1 times 4y squared. But you are not going to be adding the y dx because you are not differentiating y. Then minus, if you differentiate y squared, you'll be left with if you're having 5y cubed times what you differentiated, that would be 2x. Then this part you're not also going to be having the y dx because you are differentiating x. Now then you now see minus because the starting